This lesson is going to be over dividing decimals and strategies that are associated with it. Here's your warm-up. I want you to take a look at the 8 problems that I have here. And then I want you to look and ask yourself, what patterns do you notice? Go ahead, pause the video, and jot down a couple of ideas. Hopefully you've got some ideas written down from the warm-up. Now I'm going to present you with another problem. 112 divided by 7. The quotient of this division problem is 16. Without using a calculator and trying not to do any actual mental arithmetic, can you tell me what 11.2 divided by 7 is going to be? All right, what about 1.12 divided by 7? Or 0.112 divided by 7. And so hopefully what you're doing is when you're solving this problem, you are moving the decimal place along with the quotient. You're moving the decimal place that you have in the dividend here. And so as you change and have a multiple of 10 being divided out of a number when every other digit stays the same thing is actually going to be happening in your quotient. What about when we have something, a power of 10 change in our divisor? So for example, if I had something like 117 divided by 9, the answer to that division problem is 13. But what is 117 divided by 0.9? What is 117 divided by 0.09? Go ahead and think through this and see what the effect is of decreasing the divisor by a factor of 10. So as you decrease the divisor by a factor of 10, notice that here's our divisor and it is decreasing by 10 at each step. Our quotient increases by a factor of 10. Okay, and the reason why this happens, if we look at this, let's look at 117 divided by 0.009 as a fraction, writing the division problem as a fraction. I can't have a decimal in the divisor, and so I need to move this 3 times so that I have a whole number divisor. But remember, you have to be fair and do the exact same thing with our numerator. That changes our problem to an equivalent fraction that I can divide. And that would be 117,000 divided by 9, right? And so the base of that, of course, is 117 divided by 9, which is 13, and then we've got all of these zeros that we add on here. So as the divisor decreases by a factor of 10, the quotient increases by a factor of 10. And this is a really helpful pattern to make sure that you understand. Okay, likewise with our previous example, we had a dividend that decreased by a factor of 10. And so when that happens, our quotient decreases by a factor of 10. And this is a really, really helpful pattern for you to notice. What do you think happens if our divisor and dividends increase by a factor of 10? What happens if we do both? And so you can kind of play around with this, and we'll do that a little bit in class to see some more examples of patterns. All right, so look at this one. 36 divided by 2 is 18. What do you think 3.6 divided by 2 is? If you said 1.8, you would be correct. As I decreased the dividend by a factor of 10, my quotient decreases by a factor of 10. What do you think 0.36 divided by 0.2 is? So I decreased my dividend by 2 factors of 10 and increased my, or decreased my divisor by 1 factor of 10. Well, guess what? This answer is the same as the one above. It also equals 1.8, and I want to show you why that happens. Remember, we cannot have decimals in the divisor. And so if I write this as a fraction, I see that there's a decimal in the divisor and the denominator. I need to move it one spot. The same thing has to be done to the top. I have to be fair. So I've multiplied both of those by 10. And then I get to my equivalent fraction, 3.6 divided by 2, which I am allowed to do. And this just goes right back to this problem. These two are equivalent division problems. So far with the patterns we've been talking about long division problems that have a nice property at the end, that the remainder is 0. That means that the quotient terminates or stops. This type of problem is called a terminating decimal. And a terminating decimal just means that we don't have a remainder. At the end, we have a nice whole number as our quotient. But this doesn't always happen, and sometimes we get what are called repeating decimals. Repeating decimals mean that the problem is going to continue on and on forever. It doesn't end. One of the ones that you will see the most would be something like 1 divided by 3, okay, or 2 divided by 3. 5 divided by 6. These are fractions that we deal with a lot. Remember, division problems can be written as fractions like so. And if I were to take these and I were to change them into long division problems and do the math out here, right? For example, if I had 1 divided by 3, I need to add a couple of zeros, and then I do my long division the way I always would. I'm going to float this decimal up. 3 goes into 10 3 times. 3 times 10 is 9, subtract, drop this down, I've got 10 again. And then I do it all over again. 3 goes into 10 3 times. I get 9, subtract, drop this down, I've got another 0, and I've got 10 again. And you notice that this becomes a pattern. It just keeps going. And what we do is we add on top of one of the last digits, or one of the digits, a little bar. This bar is called a vinculum. It's Latin for bond. Okay, and the vinculum says that this keeps going on and on forever. It bonds these numbers together. And so 1 divided by 3 is what we call 0.3 repeating. And we say that because that 3 keeps going on and on forever. It does not terminate. The same thing would happen if you were to take 2 and divide it by 3. We would put zeros here, a decimal and zeros. We float our decimal up, and we say 3 goes into 26 times. And then I have 18, I subtract, and whoops, lo and behold, when I drop this down, I've got 20 again. And I know that I'm just going to keep getting 20. And so 2 divided by 3 is 0.6 repeating. Go ahead and pause the video and do the long division for 5 divided by 6. All right, so if we take 5 and divide it by 6, I'm going to put a decimal, add a few zeros, extend the bar, float my decimal up. 6 goes into 58 times. 6 times 8 is 48. I subtract, and I get 20. And then 6 goes into 20 3 times. 18, I subtract, and I get 20 again, right? And I see that this pattern is going to keep repeating. So instead of putting the bar over the 8, which doesn't repeat, I need to put it just over the 3. The 3 is the part that's going to repeat here. Okay, so it'd be 0.83333 and so on. Okay, and so we would write that quotient as 0.83 with the 3 repeating only. So we put the vinculum bar over the 3. So this video has been mostly about patterns and repeating decimals. Your exercises that follow will be about the same thing. All right, we'll talk more in class.